Hello everyone. In this video, we'll go over how Altium Designer can help you control the impedance of your signal routing paths through its advanced impedance solver. So we first need to access the Layer Stack Manager. And once here, you need to come down to this bottom part and click on Impedance tab. And from here, now we can add the impedance profile. So you can use either this middle button or this one here in the top. So as soon as you add an impedance profile, it automatically includes all the layers, and it also automatically assigns the reference for the layers to which the impedance is being calculated. So for example, if I click on this first layer, you can see the bottom reference is right here, and there's no top reference because this is a microstrip, as you can see here in this right image. You can of course select a different reference for this layer depending on what your design looks like, but we'll keep it here as a default, as whatever it was assigned automatically. And if you click at any layer, you'll see the highlighted layers here, which are the layer to which the impedance is being calculated, and the reference layers as well are highlighted. Signal layers are mixed layers, so they can be selected as references. Or if you have a particular player you want to select, you can do that as well. So if we click at this one, the same thing. Let's say we want to change the reference for this layer to one that is further. And as soon as I do that, you can see all these have been highlighted. So let's just keep it as the fifth layer. And you can include or exclude any layers from that particular profile. For this particular one, we'll just keep all of them, and this is a 50 ohm impedance setup. But what value do you set? Well, in general, what is important is that the impedance, whatever you choose, is controlled along the entire length of the line. And most designs will have some sort of constraint that would often dictate the impedance, such as 65 ohms for PCI. And typically the value will range between 45 ohms and 90 ohms. So we'll keep it at 50 ohms. Tolerance. Well, 10% is a common tolerance on a finished trace impedance. So let's say 50 ohm with a plus minus 10%. Then even if a 54 ohms geometry will be fine, however, it doesn't give your fabricator much room to move. So just to keep that in mind when it comes to tolerance. But we'll keep it for this example as 10%. H factor, you might need to check with your fabricator. What is a typical H factor for their manufacturing process? Typical value 2.5 maybe. We can try that. So what this setup is saying is, I am creating an impedance profile for all my layers that's going to be for single traces, and that's going to include microstrip and strip lines as well. That is 50 ohm with a 10% tolerance. So now I can either set the impedance and then calculate the trace width, or I can set the trace width and then see what the calculated impedance will be for that particular trace width. And you can see as soon as I change that, I have now 48 ohms instead, and it's still within tolerance. If I press FX, then it automatically calculates the trace width per this impedance target that I have. And all what's taken into effect to solve this impedance is what you see here. And all these values are corresponding to the properties based on these materials, which are from the material library right here. And we'll have a separate video on how to use the material library for your stack up. So for example, if we select this layer here, you can see that the thickness of the dielectric are the 0.07 and 0.08 are right here, 0.07 and 0.08. So if I change, for example, let's say this to 0.15, you're going to see everything in the right changing accordingly. And you can see that the impedance changed slightly, and here's my dielectric thickness change as well to 0.15. So let's just change it back to what it was. So every time you change a parameter, the calculations is redone automatically for you. So let's add a differential impedance profile. Let's keep it the 50 ohm as well. Maybe we can call it log 50 ohms. And the same thing, all the references are automatically assigned. One thing that is not supported yet for at least this release, if for example you have two dielectric layers between the signal layer and the reference. So for example, as soon as I added this additional layer, you can see here an error just popped up, and if I hover it says unsupported transmission line configuration. So just to keep that in mind. So let's remove it. So for differential, you need to change the type to differential here on the right. And as soon as you do that, you can see that there's an additional parameter that's being calculated, which is the trace gap between the differential pairs. So the same thing as with the single line, you can either change the trace width, and additionally you can change the trace gap and then calculate what the impedance would be for that trace gap if your design for whatever reason needs a particular trace gap. So let's change it to 0.15 millimeter, and you can see the impedance change slightly. Or again, if you press the FX, it will automatically calculate the impedance based on these parameters that you have. Or if you press FX based on the trace width, again it changed a little based on that particular trace width. So now that we have this particular profile ready, we can save it. So you need to save your file, and then we can go to our PCB editor and then access our rules. Through the routing rules, we can access all those impedance profiles. So for example here, if I want to use this particular profile for the single line, I can just check this right here, and then you can see everything changed accordingly. So I have my minimum width for every layer, and you can see it's different, and all of these are corresponding to making sure that my impedance is controlled within 50 ohm and within the tolerance. So if we go to differential, is the same thing. So let's add maybe a new rule, and let's say for diff pair class, and we can select clock, and now we can use this differential pair profile specifically for this differential pair class. And once you select it, you can then change the priorities to ensure that the specific rule for this class will supersede the general rule for other differential pair rules that you have. And that's how you use it. And to document that, you can add it to your draftsman, to your project documentation, by simply placing the transmission line table. And once this table is generated, you can see it includes all the impedance profiles you have created for your design, which includes the type of transmission line, the impedance target, and the calculated impedance, and of course for which layer, and the reference layers as well. Thank you for watching.